Very good morning, my dear students. Hope you all are fit and fine. Now, in the previous lecture, we have discussed about how to find out the metallic cations by using sodium hydroxide solution as a reagent and potassium hydroxide as well. As I already told you that the result either by using sodium hydroxide or by using potassium hydroxide are same. Now, today I would like to discuss how we can find out the detection of metallic cation by using this reagent, that is ammonium hydroxide solution NH4OH. So today we will discuss about using this reagent, that how by using this reagent we can find out the metallic cation in the unknown salt sample. I believe reagent all of you know, as we have already discussed that the chemical substance which is used to find out the composition of this salt by reacting with the salt, that is known as reagent. There are not many reagents which we use in our laboratory. So in this chapter, 3 reagents are there: sodium hydroxide, potassium hydroxide and ammonium hydroxide. So let's start by the first cation, that is your Cu2 positive. In the same manner as we have done in case of sodium hydroxide and potassium hydroxide, here also for finding this cation, first of all we have to prepare the aqueous solution of the salt. Take that aqueous solution in the test tube, then add smaller amount of ammonium hydroxide, that is NH4OH solution into it. It will give a pale blue precipitate. And if you will add a little amount more into this, then it will give a dark blue solution. It means precipitate will get dissolved. This is a very important observation which is not there when we use sodium hydroxide solution or potassium hydroxide solution. So this is due to the formation of, here I have written, when a blue color precipitate which is obtained, copper hydroxide CuOH twice, it reacts with excess of NH4OH. It will give a deep blue color solution. That is due to the formation of a complex salt, that is tetraamine copper sulfate plus water. So this is the important observation, because in case of sodium hydroxide and potassium hydroxide, blue color precipitate of copper will not dissolve. But if we will use this reagent, ammonium hydroxide, the precipitate will dissolve by giving a inky blue solution. Now moving on to the next cation, for iron, because variable valency is there, again the same thing, ferrous and ferric. So for ferrous and ferric, results will remain same as we have done by using sodium hydroxide or potassium hydroxide. Any salt of iron with valency 2 will give a dirty green precipitate which is insoluble in excess of NH4OH. In the same manner, any ferric salt, here I have taken ferrous sulfate and ferric sulfate, with ammonium hydroxide solution, it will give reddish brown precipitate that is also insoluble in excess of NH4OH. So for these two cation, the result will be same for NaOH, for KOH and for NH4OH. The color of the precipitate will remain same, that is for ferrous FeOH twice, the color is dirty green, and for ferric the color is reddish brown. Now moving on to the next one, this is I have written Ca2 positive, that is for calcium cation. Now the point to be noted in this case, that NH4OH does not show any reaction with calcium salt. There will be no reaction of any sort of calcium salt with that of NH4OH. This point you have to remember, because with sodium hydroxide reaction occur to give chalky white precipitate, with potassium hydroxide also reaction occur to give chalky white precipitate insoluble in excess of NaOH or KOH, but with NH4OH there will be no reaction. So this is very important point which is there for calcium salt, that calcium salt doesn't show any reaction with ammonium hydroxide solution. Next is your zinc cation, Zn2 positive. Again, I have taken one salt in which valency of zinc is 2. You can take any other salt of zinc also with valency 2, because this whole chapter, again I am emphasizing on this particular point that this whole chapter is about the detection of cation, not the anion. So you can take zinc nitrate, you can take zinc sulfate, you can take zinc carbonate. I have taken zinc sulfate. So ZnSO4 aqueous solution you have to prepare. Then ammonium hydroxide solution. Same result as we obtain in case of NaOH and KOH. Gelatinous white precipitate, that is ZnOH twice plus ammonium sulfate. Now this ZnOH twice, again when it reacts with excess of NH4OH, again amphoteric reaction occur and it will give a soluble salt. The precipitate will get dissolved and it will give tetraamine zinc sulfate plus water. So this tetra is for this 4. Tetra means 4. Amine group NH3. Tetraamine this zinc sulfate. And this particular solution, this is a colorless solution. If you compare this with the previous one which we have obtained in case of copper, that is a blue color solution. But this is a colorless solution. And soluble salt will be formed. So for the detection of zinc cation by using ammonium hydroxide, first of all, we have to prepare the aqueous solution of the sample which is to be tested. Add smaller amount of ammonium hydroxide. Gelatinous white precipitate will be formed. When excess of ammonium hydroxide is added, the precipitate will get dissolved. And if the question is name the complex substance which is formed when zinc precipitate will get dissolved in excess of NH4OH, then your answer should be it is tetraamine zinc sulfate, which is a colorless solution because it is a soluble salt. Moving on to the next one, that is for lead. Pb2 positive for detection of lead. I have taken lead 2 nitrate. Why I am saying lead 2 nitrate? Because all of you know, according to IUPAC nomenclature system, such elements which exhibit variable valency, for such elements we have to specify their valency. That's why I am saying lead 2 nitrate. So PbNO3 twice, soluble salt, it is a soluble salt. Here you can ask one question, can we take PbSO4? No, we can't take, because PbSO4 itself is a insoluble salt. So if itself we can take precipitate, then there will be no result. So here we have to take soluble salt. PbSO4 is a precipitate. It won't get dissolved in water and will not get the result. PbNO3 twice plus NH4OH, it will give a chalky white precipitate. In case of sodium hydroxide and potassium hydroxide, you obtain curdy white, which is soluble in excess of NaOH and KOH. But in case of ammonium hydroxide, for the detection of lead cation, it's chalky white precipitate and it is insoluble in excess of NH4OH. This is the observation, that the precipitate will not get dissolved. Whose precipitate? Lead precipitate. So this is all about how we can detect the metallic cation by using the third reagent, that is your ammonium hydroxide. Let me revise once again. For copper, it will give blue color precipitate which will dissolve in excess due to formation of tetraamine copper sulfate. Again I am repeating, it will get dissolved by using NH4OH. By using NaOH and KOH, precipitate will not get dissolved. And there is a difference in the color also. By using NaOH and KOH, color is blue. But by using this particular reagent, color will be pale blue. And the solution color, the color of the tetraamine copper sulfate solution, it is inky blue. Second is ferrous. Same thing, dirty green precipitate insoluble in excess of NH4OH. Ferric, reddish brown precipitate insoluble in excess of NH4OH. Calcium, no reaction. Let me remind you students, no reaction. Calcium salt doesn't show any reaction with this particular reagent. Whereas with sodium hydroxide and potassium hydroxide, reaction occur to give chalky white precipitate CaOH twice. Here with NH4OH no reaction. Next is zinc. Gelatinous white precipitate due to formation of zinc hydroxide, ZnOH twice, reacts with excess of NH4OH to give tetraamine zinc sulfate. It means the precipitate will get dissolved and it will get dissolved to give a colorless solution. There is no color in this case, but there is an inky blue color in this case. For lead, again you will obtain chalky white precipitate, that is PbOH twice, and this PbOH twice is insoluble in excess of NH4OH. So this is how you can find out the metallic cation in the salt sample, either by using NaOH or KOH or NH4OH. These are the three reagents with the help of which we can find out the metallic cations in the unknown salt sample. So revise all these things. Thank you.